Okay, welcome back. This is part 6, intervention strategies used to prevent and control noise-induced hearing loss. So we'll talk about engineering controls, administrative modifications, and hearing protection devices. So here's a type of engineering control. If sound is generated through the pipes and the levels are too high, one way to apply, engineering controls is just to wrap the pipes in this thing that's called, a silencer. So when the wall of a pipe radiates most of the acoustic energy and an inline silencer, is not feasible, acoustical pipe lagging, this is not a silencer. Well, it is this type of silencer, but it's not something they call an inline silencer. So this is the acoustical pipe lagging can be used. In pipe lagging, the exterior surface of the pipe is wrapped with a sound absorption material. The absorptive material is then covered with a barrier material with high sound transmission loss properties. In the United Kingdom, major manufacturers have incorporated an acoustic limiter on the telephone headsets to ensure that sounds above 118 dB, and I'm sure they mean dBA or they mean dBSPL because dB by itself is a difference in levels. So 118 dB, let's call it dBA, are not transmitted through the headsets. This type of limiting does not differentiate among speech and non-speech signals and can cause speech output to be distorted or masked. Such distortions can increase stress levels of call center operators because of the required extra listening effort. New algorithms incorporating the combination of compression and limiting technology, similar to that used in hearing aids and actually similar to that used in cell phones these days, have been proposed to reduce the level and distortion of speech during shock onset. The shock that they're referring to is the shock from unexpected and high levels of sound coming through the communication system. Acoustic panels have been used in a room to absorb some of the sound. So the materials used in the construction of the panels, the efficiency of the materials to absorb the sound is described by a sound absorption coefficient. Absorption coefficients for some common materials are provided in this table 3-4 that I'll show you. Acoustic panels can reduce reverberation and promote communication ease when undesirable room reflections are reduced. So this is a table, and it shows you the noise reduction coefficients over here. And here's some absorptive material. These are the sound panels over here, these polyester urethane foam panels. You can see they're of different thickness. And then also you have a heavy carpet on a concrete, or a heavy carpet on felt, or heavy carpet on foam rubber. So you can see that the noise reduction coefficients are lower here for these materials. And as we go up and as you get into the thicker panels, then you see a higher noise reduction coefficient. And the greater the noise reduction coefficient, the greater the sound absorption. And so we're talking about environments where you have a room where the walls are mostly bare, and when somebody's talking, the sound is bouncing all over the place. That makes communication pretty difficult. And actually, you could think of it in terms of the room reflections or the echoes as basically an extra noise that's in the environment. So it makes speech communication difficult. And let's see over here, as the panel thickens, as the panel thickness increases from 0.5 inches to 2 inches, the greater the sound absorption coefficient, especially in the low frequencies. So notice it says octave band center frequencies over here. These are the lower frequencies, and these are the higher frequencies. So as the panel of as the thickness of the panel rather increases from 1/2 inch to 2 inches, you see the noise reduction coefficient actually increases. So if you want to decrease the room reflections for low frequency information, like a bass guitar or any low frequency sound, you want a thicker panel. Okay, and then we have less increase in sound absorption as seen in the high frequencies as the panel thickness increases. But the sound absorption is actually already pretty high for the high frequencies. So the thickness of the panels is mostly controlling the reflection for the low frequency sounds in the room. This is actually my home studio. I still play music. I still play drums. I have bands over the house. And these are the acoustic panels that I had installed in our room. And these are 2-inch fiberglass sound panels. The room is like, I think the ceiling is 11 feet tall. And the noise reduction coefficient is a 1.0. So they do a real nice job controlling the reverberations in this room. Okay, exposure, this is really fascinating. Exposure to noise below hazardous levels, which is below 85 dBA. Exposure to noise below the hazardous levels specified previously, medium level noise, has the potential to cause the following non-auditory effects on health. Cardiovascular dysfunction, wow. Changes in breathing, annoyance, sleep disturbance, and related physical and mental health effects, and interference with speech recognition and communication, and interference with tasks requiring a high degree of attention and concentration. So even in conditions where the noise is considered below hazardous levels, there's a lot of problems that the workers can experience. So these are important to know about. There's also something called administrative controls to reduce noise exposure. So this is not earplugs. This is not paneling on the walls. This is not, putting this lagging around pipes. This is just administratively, we're going to move the personnel around to reduce their exposure to high levels of sound. So for workers who are exposed to hazardous noise doses, even after the use of engineering controls, one choice is to revise work schedules to limit the duration and intensity of noise exposure levels. For example, instead of one worker assigned to a duty that results in high noise exposure level during the entire day, 2 workers can be rotated through the task. The advantage is that both workers can perform relatively quiet duties for half a day. The disadvantage in such cases is that both workers are exposed to noise of concern. Let's talk about some hearing protection devices. So again, I worked as a hearing conservation technician for a short time at the Arco oil refinery in Carson, California. And this is what I'd see sometimes. The workers would come in with their earmuffs, excuse me, which they were required to wear, but it bothered them because they weren't able to communicate in the workplace so efficiently. They weren't able to hear. So this is what they would do. They would literally take a drill and drill their initials into the muffs themselves to improve speech perception in the noisy environments. Of course, once you drill holes in these things, you're actually defeating the purpose of the earmuffs. So they would wear them just for show, so they didn't get fired, but they drilled their initials in there so that they could actually hear. So this is like a totally bizarre situation. There's something called a noise reduction rating, or NRR. The NRR is a single number rating which is required by law to be shown on the label of a hearing protection device in the United States. The required formula used to determine noise reduction rating includes an adjustment for individual variability and for those persons who do not wear hearing protection as instructed. NRR is computed from laboratory data that are not representative of the values attained in the real world by actual users. This is from a website for a company called Etymotic Research. Etymotic Research makes some really cool in-the-ear monitors, some great stereo earbuds, if you will, and they also make some very nice hearing protection. Okay, so we have our Osha guidelines and our NIOSH guidelines for maximum exposure levels, and the level of exposure, maximum permitted exposure, is dependent on the time of exposure. So the lower the level of the sound, the longer you could be exposed to that sound in that environment. So know this, rock band concerts have been measured at 115 dBA. According to Osha, the maximum allowable exposure time at this concert would be 15 minutes. So here's the concert at 115 dBA. This is the sound level reaching the ear, right? 115 dBA, and according to Osha, the maximum time of exposure is 15 minutes. But look at NIOSH. NIOSH is a lot more conservative. The maximum amount of exposure is 28 seconds. 28 seconds. Imagine getting dressed up, going to a nice concert, and if they followed the NIOSH guidelines, they'd say, okay, we're going to pull the plug after 28 seconds, which would probably be like really annoying. So with the greater attenuation provided by the earplugs, and you get these values from that noise reduction rating, the greater the attenuation provided by the earplug, the longer that you can be in that environment. So if you have a nice earplug with 30 dB of attenuation, and you're in an environment that's at 115 dB with 30 dB of attenuation, now the level in the ear canal is only 85, and the maximum amount of exposure is, what is that? I think that's 16 hours, according to Osha, and it would be 8 hours for NIOSH. So an 8-hour concert might be more, I don't know, 8 hours, you probably get pretty bored or pretty tired of the band after that. But you see, if you wear an earplug with a greater noise reduction rating, according to Osha and NIOSH, you're allowed to be in that environment for much longer time. So as the amount of earplug attenuation increases, the maximum exposure time increases. According to this table, exposure to 115 dBA with earplugs that provide 30 dB of attenuation will give us a maximum exposure time of 8 hours, according to NIOSH. So let's take a look at some hearing protection devices. These are standard foam earplugs. If they're seated properly inside the ear canal, they offer 27 to 33 dB noise reduction rating. But a shallow insertion in the ear canal will result in greater attenuation in high frequencies than low frequencies. And a very deep insertion may result in an essentially something called flat attenuation across the frequencies. This is a very shallow insertion. This is probably doing like no good at all. And this is a nice deep insertion. And I've rolled these plugs up and stuck them in really deep in my ears because I'm exposed to lots of loud sounds as a musician. And one time I stuck them in so deep, I could not actually remove them from my ear. And I was a little nervous about driving home with this earplug stuck in my ear. That was a little unnerving. So anyway, so you have a shallow insertion and a deep insertion. And according to a study from the US Air Force, the deeper the insertion of the earplug, the greater the attenuation. I'm sorry, this got a little messed up here. With this deep insertion, there's 22 dB of attenuation. And so that's pretty good, right? But this earplug, there was 0 dB of attenuation. So as you increase the insertion, you get greater and greater attenuation. So the deeper the earplug insertion, the greater the attenuation. These are called Sonic 2 earplugs. Unfortunately, I've seen a lot of musicians wear this plug. They're actually designed for gunshots, right? It's designed for the reduction of high impulse noise like a gunshot. And the attenuation rating of these is only 6 dB NRR. Recall that some rock bands are coming in at 115 dBA. So 6 dB of attenuation is not going to reduce the sound very much. Here is an earplug. It's called Doc's Pro Earplugs. I met Doc at a conference. Doc is a physician. He created this thing. It's sort of a cover that sits inside, just outside the ear canal. Now, this is an earplug with a hole in it. This is an earplug with a hole. Remember the earmuffs where the guys would drill their initials in the earmuffs, defeating the purpose of the earmuffs? That's what this does. This is a disaster. Excuse me. So this is the vented plug, the one with the hole. Look at the noise reduction rating. It's only 2 dB. And then the unvented is 7 dB. So it's a little more, but it's not much, right? I saw a young lady who's all punked out. This is at a music merchants conference in Anaheim, right across the street from Disneyland. And this young lady was all punked out. She was a bass player. And I saw her wearing these. And I came up to her and I said, excuse me, I got to tell you, those plugs that you're wearing, they aren't very good. They actually have a hole in it. And the noise reduction rating, I sort of went on to my audiology thing. And then she looked at me with these wide eyes and she said, well, I'm so glad you told me this. She said, you know, these things don't seem to work because my ears ring all the time. And she's playing bass in a punk band wearing an earplug with a vent that's given her like 2 dB noise reduction rating, which is, like I said, it's a reduction. I mean, it's a disaster. Oh, here's something really lovely. I don't even know if they make these anymore. These were called ear filters, a filter, not a plug so you can hear. A filter, not a plug, so you can hear. Designed by a musician for musicians. Ear filters filter sound, allowing you to enjoy the amplification with full clarity without the side effects of ringing in the ear, headaches, or possible hearing loss. So these things are going to protect your ears from hearing loss, and your ears aren't going to ring, and you're not going to get headaches. And let's look at the noise reduction rating. 0 dB. It's on the package. 0 dB. Notice they spelled dB wrong. It's supposed to be a small d. 0 dB. And on the package it says, try them. Hear for yourself and enjoy the sound. Yeah, notice it says that the ear filters sound designed by musicians. Ear filters sound, allowing you to enjoy amplification with full clarity. Yeah, because they're not doing anything. And then it says this product is absolutely not to be used while firing any type of firearms. This product actually should never be used at all. Look, they got a patent. They got a patent for this thing. That's just stunning. So there are things called custom molded plugs. Remember, we said the truckers, according to the DMV code in California, way back when, allowed the truckers to wear custom earplugs. To get a custom earplug, you need a mold taken of your ear canal and of your ear, and then this is sent to the company, and then custom molded earplugs are made. So a solid custom earplug can offer up to 30 to 45 dB of attenuation across audiometric frequencies. And I have a set of these with the canal portion is very deep, and that offers a lot of protection. So I'll use that if the band is playing really loud. There's this beautiful plug called the Musician's Ear Plug. It offers a flat attenuation or high fidelity custom plugs. Let's see, they have an interchangeable filter. These are the filters right here for various degrees of attenuation: 9 dB filter, 15 dB, and 25 dB. So if you're in a noisy situation but it's not real loud, you can get 9 dB of protection. If it's a higher level environment, you can use the 25 dB filter. And I have these in my stick bag. I use these when I perform. So this, again, Etymotic Research. Etymotic Research is the company that makes the Musician's Ear Plug. They created that plug, and then they have an over-the-counter version, which is quite nice. It's called the ER20. You can get them on Amazon. You can get them at different places. Several companies distribute these same plugs. They're called a high-fidelity earplug. 20 dB of attenuation across audiometric frequencies, though the noise reduction rating is only 12 dB. But still, these are very nice plugs, and I use these. So that ends our lectures on various topics on auditory disorders and occupational health. I can be reached at my email address if you have any questions. All right, it was nice talking to you all. Take care.